Hello and welcome to Drilling Insight. I'm Jeremy Verduzco, host and editor of the Driller magazine. I'm joined today by drilling trainer, the driller writer, and co-host Brock Yorty. How's it going, Brock?
Doing good. It's gonna be a good week. It's good. It's March. The weather's getting warmer. I think we're out of this crazy winter stuff.
Yeah, I will definitely look forward to the end of that tunnel. So joining us also on today's show is Scott Dalrymple. Thanks for being on the show, Scott. Welcome.
Hi, my pleasure, Jeremy, and thank you so much for having me here with you and Brock today.
So Scott is a design engineer for Meditech and product manager for their drilling division, Borterra. Now, we brought him on today to talk about a prototype rig that his company built for a dam project in Alabama. Brings together down the hole water hammer and sonic technologies, a mashup that allows the driller to switch methods as required to keep holes on target. So with that, let's get started with our first question. Take it away, Brock.
So, Scott, did you choose the industry or did the industry choose you?
So, good question. I'd have to say a bit of both. The choice to become a mechanical engineer was an easy one for me. I was a kid who grew up always wondering how things worked and liking technology and, trying to fine tune my motorcycle to make it run faster, stuff like that. So after graduating from university, I didn't really know what I was going to do. And then just fortuitously, I took a tour of a mining equipment manufacturing company. And when I saw this big equipment with hydraulic cylinders and motors and gears, I was hooked. And that one tour ended up defining my 30-year career. And honestly, I've never looked back. Over the course of my career, I've designed all sorts of different mobile equipment, heavy equipment. But it was in 2012 when I really became focused on drilling. I accepted a job in Winnipeg, Manitoba with a company called Cubex, which was a world leader in ITH drilling, drill rigs. And they got bought out later by Sandvik. And then it was while I was working as design engineer and engineering manager with Sandvik that I got introduced to Meditech. Occasionally we'd get overwhelmed and we'd subcontract some design work. And Meditech was this little powerhouse of a firm that was a mixture of experienced engineers working alongside some really talented, ambitious young guys. The culture was one of creativity and enthusiasm. And Meditech could design and build us a drill rig in about the third the time it took to do it with a big company like Sandvik. So after working with them, as their customer for 3 or 4 years, when I was given the opportunity, I jumped ship and I started with them. And I've been with Meditech now for about 3 years and just love it.
Mm-hmm. Okay, so I mentioned at the outset this project in Alabama. Can you, I guess, give us kind of the postage stamp size description of what this project is, what the goals were, and how did Meditech Engineering and Borterra come to get involved with a project like this?
Yeah, well, sure. The customer in this case is Alabama Power, which is a division of the Southern Company, a large utility down in southern states. And they were customers of Cubex, the people I mentioned I formerly worked for that then became Sandvik. Their Logan Martin Power Dam operation had a Cubex QXW, which is a self-contained water hammer ITH drill rig. It's got rods on board, it's got rod handling, and it's ideally suited for doing dam rehab work. These guys used it for drilling grout holes, which meant installing casing down like around 100 feet and then drilling through it down to like up to 600 feet. And as part of their planning process at the dam, they occasionally needed core sampling done, but the QXW couldn't do the core sampling. So they would, and they couldn't really justify a second rig. So they would just contract out the core sampling. And the local company that made the most sense to them economically was one that did it using sonic technology. And when the rig got, a little long in the tooth, the guys put together, a group and they created a big wish list for what they wanted in the replacement drill rig. And this list included, being able to store 600 feet pipe on board as well as casing, They wanted the capability of using 20-foot rods instead of, as well as 10-footers, because the Cubex rig just did 10-footers. And they also needed to match the capabilities of being able to drill off axis in both planes up to 15 degrees in all directions. And they needed a side shift, because in their application, they often come back and revisit holes and they have to realign. On top of this, they wanted to be able to do their own core sampling. So they wouldn't, they could do it on their own schedule. They weren't stuck to the schedule of their contractor when it was available. And then as a further, item on their list, they wanted to be able to record all their drilling data, so they could combine that with their core sampling and, further enhance the 3D map of the rock structure they were dealing with. And so they went shopping and quickly found out that no one made such a versatile rig. And in fact, they said that they really couldn't find any 2 rigs they would buy that would do everything they wanted. So the geostructural services team at Southern is a pretty bright and determined group. And their supervisor, a gentleman named Eric Manning, is an engineer himself. And by his own admission, he's always looking to push for improvements in technology in his industry.
Yeah.
And he knew what they wanted to do was possible. They just had to find someone who could make it happen, So Eric found us, Meditech, and the rest is history. We delivered the rig in mid 2020 last year, and it does everything on their wish list and maybe even a few extra things.
So you covered the versatility of the rig and the wish list of what they were looking for, but on a dam project like this, what was the ultimate goal of using an alternative drilling method versus what we traditionally could have had? Was there any specifications by the engineers at the dam, or was there an integrity issue with saying conventional wireline coring or something like that?
No, I think that when it comes to the coring side of it, they could use conventional coring. I think that maybe the nature of what they were looking for, they didn't need the samples to be quite as exact, and with sonic, you can get there faster, get the sample out. And if you can live with plus or minus a foot or 2 or 3 or something like that, it's not as critical. On the drilling side of it, they had to use an ITH drill because they're going so deep. And air ITH, which is more common in the industry, you've got this compressible air that when it gets down and goes through the hammer, it then expands it everywhere it can. And they've got a lot of fractures in their ground. That's the whole point of them drilling is they want to fill all these voids that water going into the dam has caused. So really, it wasn't an option for them to use air ITH. They had to use water ITH, which is traditionally what that industry is used.
So why these 2 technologies in particular? Is there something about the 1 + 1 of these 2 technologies that equals 3 together?
Yeah, Southern's like any other drilling operation. What everyone really wants is to drill faster, straighter, and cheaper. And in addition, they want, in their case, the ability to take core samples and record drill data. So the Wasara Hammer ITH, in addition to what I just said about not using the compressible fluid to drive it, it's also known for speed and accuracy through rock. It beats compressed air on both fronts. And, especially with these guys, they had a lot of fractured ground and stuff, like sticking their bit was a big deal. And so the ITH really made sense for them. Now, their experience with getting this, various coring contractors on site pushed them towards sonic because it was doing the trick, and it was, like I said, faster and cheaper than what they're used to. So sonic's not new technology. It's been around a long time, but I think it really hasn't got as much recognition over the years, and it's starting to become more, popular these days. So with the WS6000, the drill we produce, they can switch back and forth between these 2 technologies. And it just gives the operator more tools, to overcome his ground conditions to do his job. And in reality, we're only starting to just see the potential of it. Southern is still in the discovery stage. They'll undoubtedly drive their casing down using sonic because it just flies through the overburden. But once they get there, they can switch to using sonic, or they can keep using sonic, I should say, to drill through the rock, but they probably won't because water hammer is what they know and it works faster. But along the way, if they ever get stuck, they can always just switch back and turn on those sonic vibes. They're strong, and they'll unstick their bit, quicker than they ever could have doing traditional, water ITH drilling. And then same time, if they're hitting something that's unusual, they want to know what they're into, they can pull their string out and send down a coring barrel and take a coring sample and see what they're at right there. So ultimately, having both these drilling technologies available will let them drill faster, straighter, and cheaper.
Was there any other downhole analytics they were doing, saying video logs or going in and doing, a geotechnical log or a gamma log or something like that? Was that any part of it? Were we mostly an overburden into clays, or was there some competent rock? What was the information they needed to recover?
Their main goal is to stop the water from going under the dam, because in their case, water equals electricity equals money. So their purpose in sampling or doing anything or surveying holes is really just to get an idea where the water's going. They as well, they use aerial photography, probably drones, I know, and they look at the turbulence under the dam, and they can from that kind of get an idea where the biggest focus of interest is. I imagine they used other survey technologies for their holes. I'm not actually totally sure, but in their process, it was kind of neat. Like they'd have a focus area, they would set maybe a dozen casings, and then they would, drill down, I think about 40 feet, and then they'd stop and pump grout down, and they'd keep pumping until they got to a certain pressure. And they said sometimes that was 10 minutes, and sometimes it might be 8 hours. The grout was just flowing into every nook and cranny and setting. And then they leave it and they go do the next one and the next one and the next one. They let the grout set for a week or whatever's required. Then they come back and they drill through that 40-foot plug, and they drill another 40 feet, and they repeat the process over and over. So in their process, it really was about finding the holes and plugging them.
So can you tell our audience about some of the safety features of this WS 6000, right?
Yeah, no, I sure can. I think I mentioned earlier that I've been in the designing heavy equipment for like close to 30 years now. And, when I first started out, safety involved choosing which, warning decals to put where on the machine. That was about it. But nowadays, safety is everything, and it's an element of everything you design. And I tell people, like, the holy grail for a machine designer like myself is a technology which enhances safety and at the same time boosts productivity, because for years they went in opposite directions. So the WS 6000 has two significant technologies that in my mind do exactly that. And the first one is the operator cab. And I'm going to switch my background here. You can see the front of the cab that way. I'll switch it here, and you can sort of see the big window is what the operator will be looking at when he's drilling, and then the other two windows are on the other side. And on this cab, it's enormous. He's got a nice big comfortable seat, and he's got windows on all four sides, giving him 360-degree visibility. It's a big machine. When he trams it, he's got some blind spots. So we've got a 4-camera, HD camera system. We also have cameras trained up in the mast, so he can help out there if it needs. The cab itself swings out when he's drilling, so that he's directly in line with the drill string.
Okay.
This massive window in the front goes right from his feet up above his head. So it means that he can see his jaws down below. He can see his threads at the top when he's trying to couple into a 20-foot rod. And then, to give him this unfettered view and meet all the requirements for code, the front window is actually made of a bulletproof acrylic with a steel reinforced frame all around it, because it's conceivable that one day he might swing a rod into this thing.
Yeah.
And but now he's got a nice clear view. He's not stuck looking through grizzly bars. You can see the top of the cab, I guess it's up here.
Yeah.
That window is subject to some different codes because there's fall-on protection. We had to put grizzly bars on that. And, typically a piece of underground equipment like this or surface drill equipment like this has those bars, and you eventually see through them, but it does, hamper what you're seeing. So the big clear front window we saw is a big plus. Now, the problem when you build a cab with clear windows is it tends to get hot. And when you're outside, you typically tint all the windows, and that helps with the heat and everything. But then when the sun goes down or it's a cloudy day, you can't see as well. So we've actually put photochromatic coating on all these windows, and that's the same stuff that people put, you get the sunglasses to change color when you go in and
Yeah.
out. So we have that on all the windows. So it's shown here in a fairly bright day, and it's got like dark tint, which helps keep the cab cool. And it also allows the guy to see out without squinting.
Mhm.
And I don't really have a good picture to show, but when the cab's on a clear day, or sorry, on a cloudy day, it transitions as or as the sun goes down, it transitions to fully clear.
Huh.
So
Okay.
it's best of both worlds,
Okay.
And then the second safety feature, and honestly, the most impressive thing about this whole machine is the rod handler. It's the red thing behind me here. And here, where's a good view? There it is on its own.
Yeah.
And when the guys were, here's another picture. When the guys were building this in our shop, someone along the way started nicknaming it the Rod Bot, which was a combination of rod handler and robot, and
Yeah.
that name just stuck. So now we've got the Rod Bot on the Southern machine, and it's turned into something, something we think we can sell as a product on its own. So the Southern guys, the reason it came about is the Southern guys, on their wish list, they wanted to allow a single operator to load and unload 10-foot and 20-foot drill rods and casing, and it all had to be done from inside their FOPS certified cab. And all this had to happen without slowing down the drilling process. So,
Okay.
and for the record, a 20-foot piece of 7-inch casing weighs about 700 pounds.
Mhm.
So if you think about it, the automotive industry has realized for years that the heavy lifting is best done by a robotic arm, but the drilling industry is just starting to catch up.
Mhm.
And as a designing company, we actually looked for other technology we could buy or license, and it just wasn't out there. So in the end, this is something we designed and built from the ground up ourselves. And the operator can use it manually as an extension of their own arm. We've got
Mhm.
intuitive controls, or they can utilize the robotic control software and have it load and unload pipe following a predetermined path, which the operator can set. And it does this with little or no operator involvement.
Mhm.
We're pretty excited about this technology on its own. We think it'll help sell our drills, but we think it'll also be something that we sell and mount on other people's drills, or even on dedicated rod storage systems.
Yeah.
I think something like 30 to 50% of drilling operator injuries are a result of rod handling. And the Meditech Rod Bot is a true hands-off rod handling solution, and it improves both safety and productivity.
Yeah.
So I got a couple questions here as we've transitioned into the safety phase. How many individuals are working on this rig? What does a drill crew look like that's on this rig?
A lot of the time it's just one, and it is designed for a one-man operation. When they're sampling, they don't have to, but they'll often have a second guy recovering the samples. And that's, I don't know if you're familiar with that procedure, but it's
Very.
Yeah, I'm sure. We've given them a remote control, so a single operator can align his sample bags and rattle his sample out into the bag himself.
Mhm.
But a lot of times it'll be done probably with two people, in which case we've set up the controls so that the remote control has full control. So the guy with his hands closest to the thing can't be overridden by someone who accidentally hits a joystick or something like that up in the drill rig, if that makes sense. But most likely in that case, it'll be two-person operation. The guy will use his remote control. He'll, you tilt the head, you rattle a sample out of the coring barrel, and then he'll label it, put it on a rack, and then the other guy will take over and go down for the next sample.
Okay, yeah, that's exactly where I was going. So then when we go to core barrels and core recovery, is the operator getting out of the cab, or we have a second individual that's on site?
Probably they'll do it with two, and that's what they've indicated to us. But it's the controls are set up so a single guy could do it. He would trip his rods out with his core barrel full, and when you're using 20-foot rods in the Rod Bot, you can trip out, pretty easily. And then he could jump out and run around and rattle out his core sample if he wanted to, using his remote control. But I don't think they'll do that. I think they'll have two guys.
I was just going to say, our industry has been pushing for hands-free rod technology, and there's a couple different systems out there, but I like the elegant design here and the ability to get our people out of the danger zones. And that's a fantastic thing that you guys have done.
Yeah, thanks. I mean, it's no small feat, especially in this case, because that mask can line up, at a whole variety of angles. And so the rod bot, is what we call it, has to be able to match that angle. And because of the electronics involved, the default is it matches the angle and is about 2 feet out, and the operator steers it in, and then it can record that path and replicate it. And so it's, we also partnered with a company that does robotic control software, and we can program in exclusion zones with collision detection in 3 dimensions real time, so that the rod bot on its own will pick the fastest path, but avoid hitting stuff with the rod along the way. So it's really, we've met the needs for this machine, but we've actually run with this and made it a technology on its own we can sell, and it's completely versatile.
Yeah, and just looking at it, it really evokes the kind of robotic arms that you might have seen on, like you mentioned, auto assembly lines. It is a really interesting piece of technology you have there.
Yeah, no, thanks. And actually, as a design engineer on the job, I started out thinking we could capitalize on existing robots, but there's tons of them, but they're all electric. And for a while we thought, okay, maybe we can put a hydraulic generator on board, and we can, because this thing has to be standalone diesel. And but that just didn't make sense. So what really makes this different is that it can lift heavy weights. It's fully autonomous control, and it's hydraulic run.
So as a proof of concept, has this gotten any attention for your company, or brought in any kind of other opportunities where the other utilities look at that and think, oh, I need to get one of those, or whatever the customer might be?
Yeah, we've actually been approached by another utility. We've also been approached by a couple different sonic drilling companies, who realize, the potential for speed if they can get down to their sampling. If they're not sampling the whole way down, and they can get down to depth using a different technology, and then with the same company switch, or the same machine switch over and take their sample.
Yeah.
So it's definitely gotten attention that way. We and the rod bot too as well. It has application in all industries. We've been getting interest from oil and gas as well as mining operations.
For sure.
I'm very impressed by this system, and you guys taking your customers' feedback and innovating in so many different ways that we haven't seen in our industry. Where are you guys going next? What's the next innovation? You guys got a rock melter out there? Is there like levitation device? What do we got?
Well, I like to tell people that I hope in my lifetime I see a version of the WS-6000 drilling asteroids, and dropped off by a Falcon X or a SpaceX Falcon 9 rocket. But in the immediate future, we're going to continue to work with Southern. As I said, it's a process, and we're learning from them. They're teaching us. We've got to realize the full potential of this drill rig and their application, which also gives us another basis to sell it by, and then we're also following up on some of these new leads with other customers. We're excited about sonic drilling. As I mentioned before, it's been around for decades, but it's not that well known, and we've now become quite knowledgeable in its potential. As you sort of alluded to, I'm representing, Meditech, and we're taking credit for this drill, but in reality, it started with a bunch of guys down in Alabama, who were smart guys who knew there was a better way to do the job. And, Meditech made it happen, but originally it was their idea. So, Jeremy and Brock, maybe some of your viewers right now, have some ideas something they want us to build. I sure hope so. And I hope they give us a call, because that could be our future.
Yeah, so Brock had touched on looking ahead, but talk about a little bit more about the market for a rig like this. I mean, of course, there's a lot of dam remediation out there, and we always hear about how infrastructure is in such a state, particularly in the U.S. I'm not sure about up in Canada, but are there other types of work that this particular combo could be applied to?
Well, you know, for sure, we think everyone should have one, you know, but I mean, dam rehab is a big market for sure.
Yeah.
This machine is very versatile. It's a bit of a Swiss Army knife. You know, there's not much you can't do it. I've said before, hey, if you want to use it for setting post holes or drilling water wells, you know, you could.
Yeah.
And but in reality, it's you know, it's capable of so much more. But the one thing is for, you know, a contractor, if he owns a hybrid drill rig, you know, it's not going to hold him back at all, and it might even let him bid on jobs or be more competitive on jobs, you know, just because he's got that extra tool in his toolbox.
Mhm.
And, you know, in addition to dam work, we for sure see potential for construction, you know, geotechnical, you know, road work and foundations and stuff like that, as well as mining.
Yeah.
We also expect that we'll sell smaller versions. This is like the fully loaded Cadillac. You know, not everybody needs onboard storage, especially so much, and not everybody needs 20-foot rods. You know, it's, I think, an industry standard, and Brock, you can tell me if you agree, but 10-footers are more of an industry standard, but you know, 20s are nice to have. So, you know, in our case with dams, the sonic water hybrid combination works, but for a lot of applications, I'm sure it'd be a sonic air ITH would be a better choice, you know, because not everyone can drill with water.
Well, Brock, did you have any more questions for Scott while we're here? You seem very interested in the system, so I want to make sure we're getting all your questions answered.
Yeah, I think everybody out there with Waterhammer is going to want to know this. What was the process for running the Waterhammer? Did you guys have a big water truck? Is there a hydrant? Are you recirculating water for your Waterhammer? This is the $1 million question that we get very often when we talk anything hammer that's Waterhammer. What was that like?
And that's a good question. You know, in my career, I've worked on all those scenarios with, you know, filtration and circulation systems. In fact, right now, Meditech's quoting on one for somebody who has to recycle the water just because of the location. You know, truck it in. They do use a lot of water. This one maxes out at about 120 gallons a minute. You know, at 3,000 psi. If you're not recycling your water, use a lot. In this application, I mean, it's a dam. You know, they got lots of water. They're right beside it. So they've got a pumping station right there and some filtration. You know, we've got on board filter bags that bring it down to 5, you know, microns, and we've got a water tank on board that holds enough water that the thing can run for about 2 minutes flat out, which allows them to disconnect their water if they have to drive over the line or for any interruptions and that sort of thing. It also allows you know, in this case, they can keep up with that 120. When the hammers wear out, they use more water, but a lot of places don't have that much. They might only have 80. Well, we've got a surge tank, so you know, you fill up the surge tank, you run it down. You might be using more water than you got coming in, but the surge allows you to keep going more. And then when you go to switch out your rods, you're filling your surge again. And it's so, you know, if you're gonna you have to truck in your water for sure, you're gonna want to set up settling tanks and you know, filtration systems, which we have done and we can quote on. There's a certain, you know, particle size and requirement that Wasara in this case wants you to meet, and it does require some serious filtration. But it's probably most practical, honestly, in a job like this where there's plenty of water around and it just drains back into the lake. You know, they do have to be careful. They can't put additives in or anything like that because they can't pollute this water.
Yeah.
Yeah.
No, that's great information. In my years of different projects and whatnot, I've worked on some zero discharge solids control systems, and water hammers have always been one of those valuable tools. But how do you handle the fine grain size cuttings that you have coming back, dealing with the turbidity, and then, you know, it's silly for me to have asked because of course you're on a dam, but you know, in other situations you're going, man, where do you continue to feed 120 GPM a minute, you know,
Yeah.
to progress the job?
Yeah, and undoubtedly you need settling tanks and you put flocculant to get rid of some of the turbidity. You never get to 100%. So you're always adding a little new water. and having to deal with all the sediment as a result. But you can certainly get your consumption way down and still use it. It's just the situation requires that you need to use water drilling, and then you make it work.
Yeah. All right. Well, with that, we can wrap up today's episode. I'm just, one thing that strikes me from this conversation is I'm always amazed at the innovation that folks bring to this industry. And I had never seen these two technologies put together before, but really I think it's fascinating that when you put them together on the same rig, they kind of complement each other. So what did you think, Brock?
I've always said that the best R&D and concepts for new rigs, innovation come from collaborations with a contractor and a very nimble, intuitive engineering group. And that's what we're seeing here, is that a group that went, yeah, we can do that. Oh, we want to do a robotic manipulating arm that can do that. Yeah, we'll put this together. And now we have this innovation that's just, it's cutting edge, and it's great, and it's elegant, and it's what we need to see more of. And then you put the cab and the ballistic glass and everything they've done to remove our teams from being in the danger zone and in a climate controlled environment. It's of course this is going to be the rig that goes to the asteroid, and I'm excited to see it.
Well, as long as I can be inside the cab on the asteroid and not outside, I'll be good. So, but thanks again to Scott Dalrymple. Where can the audience find out more about you, Scott?
Visit our website, which is www.medatech.ca. I'm imagining you can edit it in across my face here, but it's MEDATECH, which actually stands for Mechanical Engineering Design and Automation Technology. But when people Google it, they get all kinds of medical answers. So it's probably not the wisest name in hindsight. But anyways, visit Medatech. It's got all our contact information, or they can get a hold of me directly. My email address is sdalrymple. Once again, hopefully you can show that. Dalrymple's not the most common name, but it's DALRYMPLE @medatech.ca, and .ca because we're a Canadian company, although most of our work is in the States and all over the world. But, yeah, we look forward to it. Give us a call if you've got an idea. We'll talk to you. And like you said, Brock, that's where real innovation comes from, is listening and just trying those crazy ideas, and from people who do it every day and who come up with the best ideas.
Well, thanks again, Scott. And of course, you can find fresh episodes of the show on our website or on Apple Podcasts every other week. Just search Drilling Insight and hit that subscribe button. And don't forget to visit thedriller.com for the latest industry news and views. And of course, follow us on the usual social media channels. So until next time, this is Drilling Insight.